some of you may know this conversion already, but what if we had to convert over? What would we do?
Take 2.54 multiplied by 36.
Why?
Because it's 36 inches in a yard.
Okay. Times the fact that there are 36 inches in 1 yard. And that would kind of scrunch that there, but when things cancel out, we'd be done with inches, and we would have centimeters per yard, which is 39.37. If you ever flipped a meter stick over, or 39.37 inches in a meter. A little bit less for the yard. Alrighty, 25. What factors affect precision? So why is precision good, or why might it be poor? What does precision mean? Or maybe what's another word that we could use in place of precision? Or to describe it, Steve?
Consistent.
Consistency, reliability. Okay? So how do we know if we're precise with our measurements? They're all close to each other. So we're able to repeat a measurement many times using a particular measuring device. Yes?
They got locked out.
Should we put that on tape? They got locked out and had to interrupt. Good. Why might our results, our measurements end up being imprecise or not very precise? What might have happened? Eli? You read the measuring device incorrectly? Something wrong with the measuring device. Maybe the ruler has a chewed up end and you think you're starting at 0, but really you're a couple millimeters in. What else? Yeah. The object is oddly shaped, so it's hard to line up and measure correctly. Human error. Maybe our measuring device will only go to so many decimal places. Okay. Alrighty, now number 26. You're going to be given a specific set of measurements. You're actually going to get a data table with students A, B, C, and D, and they will have run 4 different trials, and you're going to see what results they got for 4 students, 4 tests. Okay? And then you're going to be asked some questions about that relating to accuracy and precision. We need to be able to look at that data table and figure out which student's data is precise and which student's data is accurate, or both, or neither. So let's do that in kind of a shortened form. We have measurements of 1.36, let's say these are all centimeters. 1.36, 2.36, 1.98 for one student. We have 1.45, 1.48, 1.44 for another student. And we have 2.11, 1.98, and 2.02 for the third student. And all centimeters. And the accepted value is 1.50 centimeters. Okay. Who was precise? We have students A, B, and C. Who was precise?
B and C.
B and C were precise because their measurements are within a reasonable degree of uncertainty, plus or minus 0.0 something. Okay, not too very far off. What is wrong with A? accepted value, but not really. Okay? Which student is accurate, if any? Student B. Okay. So it's not right on the accepted value of 1.50, but it's pretty close, and the results are consistent. So B is both precise and it's the best accuracy of our three choices. Okay, so you're going to have a data table like that. You'll need to look at the numbers inside and make comparisons like this. Now, something that happens on questions like this. When you have answer choices like A, B, and C, and it relates back to a picture, when the program scrambles the answer choices, the letter doesn't always match the answer choice number. So, on one version, answer choice A might say student A, answer choice B, student B, and answer choice C, student C. But on another version, answer choice A might say student C, and answer choice B might say student A, and answer choice C might say student B. And that will be frustrating because you're going to look at the data and you're going to know exactly what the correct answer is, but you got to watch the choices. So that happens pretty much, well, every test where there's pictures or something like that, you're going to see that happening. So pause on those questions and make sure that you're looking at what the answer choice really says. Okay, that will be very important because you'll know the right answer, but miss it because of a formatting issue. Okay? 27. Each of the SIGFIG rules, especially for zeros. So what can you tell me about zeros that come after numbers but before decimal points? Zeros after numbers but before decimal points. Can we give me an example of a number like that? How many? 300? 300 grams. After number, before decimal point. What do we know about those zeros? Michael? They don't count. They are placeholders. Placeholders. How about zeros after a decimal but before a number? Like the opposite. Those are also placeholders. Okay, not significant digits. How about zeros